Hello again, another day, another exam paper. This time it's paper 2 from June 2022, the higher tier paper for Edexcel Maths. So I'm going to talk you through the questions step by step, every single question, and I'll try and be as to the point as I can without rushing too much as well. But that said, I don't want to take forever because I appreciate that spending hours listening to a maths video isn't probably what you're here for. You just want to know how to do it fairly efficiently. So on that note, I'm going to shut up about the introduction and get straight to talking you through question number 1. Question number 1 comes in 3 different parts. First of all, expand x cubed to the power 5. So x cubed to the power 5 basically means x cubed multiplied by itself 5 times. So the very slow way of doing it would be x cubed once times itself twice, thrice, 4 times, 5 times, then just add up the powers. 3 plus 3 plus 3 plus 3 plus 3 gives us x to the power 15. I hope you did it the quicker way and just remembered that to find a power of a power, we just multiply the powers together. 3 times 5 is 15, so we have x to the 15. Part B, we have to expand and simplify this one here. So the first thing is to expand 4 lots of x plus 3. 4 times x is 4x, and 4 times 3 is 12. We then do exactly the same thing to the 7 brackets 4 minus 2x. So 7 multiplied by the 4 gives us a positive 28. And then 7 multiplied by 2x would be 14x. But because it's 7 multiplied by minus 2x, that gives us minus 14x. You then compare and combine the like terms. So in terms of just the normal looking numbers, we've got positive 12 and positive 28. 12 add 28 is 40. Whoops, I didn't mean to do that type of pen. That's a bit strange. So we've got 40. And the x's, we have 4 x's over here, and we're taking away 14 of them. 4 take away 14 is minus 10, so 4x minus 14x is minus 10x. So that's the answer for that one. You could have also written minus 10x plus 40 if you wanted. Part C, factorise this one fully. So look at the numbers in front first. 15 and 3, they both have a common factor of 3. Both of these terms have x's in them. Each one has at least an x squared. That's got an extra x, that's an x cubed, but they have at least an x squared in both. There's only a y in that one, not a y in that term, so y isn't common to each, so can't be factorised out. That's all we can factorise out. Once we've done factorising out, we open up the brackets. I've got 3, I want to have 15, so I multiply the 3 by 5 to get 15. I have x squared, I want x cubed, so I need to multiply by an extra x. Plus sign, so stick in a plus sign. I've got 3, I want to keep it as 3, so keep it as 3 times 1. X squared, I want x squared, so don't times by any more x's. That'll give me something like x cubed, which I don't need. And finally, I do want a y, so I take 3x squared and times it by a y. Now, even better than that, as you should know, if you've just got one y or one x, you can just say it's just simply y. So I'd say a better answer might be 3x squared brackets 5x plus y. It is better form to not put 1y, but to put simply y. So this answer is preferable. Question 2. Describe fully the single transformation that maps shape S to shape T. Just be careful which way you're going. Don't do what I nearly did and think about going from T to S. We go from S to T. What I'd suggest, or what you might want to do, is to trace around the shape first. You don't have to. And then just think about any point on the shape. So I'm going to pick the top right point here, like so. I'm going to think what I'd need to do to get it from that point here to this final point on T where it needs to end up. So you can go up or down first, or left or right. It doesn't really matter as long as you remember what each direction means in terms of the vector. I'll come to that in just a moment. What I'm going to choose to do first is to move this up the green line so I can get to this green dot. So I need to move up 6 units. Count them with me if you'd like. So 1, 2, 3, 4, 5, and 6. That then takes us to this point. So then I've moved 6 units upwards, like so. Then what I need to do is to obviously move to the left. I need to do this 1, 2, 3, 4, 5 units like so. And so the final resting place, after going 6 up and 5 to the left, I get to where the shape actually needs to be. Now, transformations are written as column vectors. The top number tells you how far to the right you've gone, and the bottom number tells you how far up you've gone. So how far to the right have I gone? Well, I've gone 5 to the left, so the top number must be -5. And how far up did I need to go? Well, I needed to go 6 units up. So it's a transformation. It's actually a translation by column vector -5 and 6. So that's how we write it down. It's gone 5 left and 6 up. So it's a translation by column vector -5 and 6. Question 3, we have the length of a football pitch is 90 metres, correct to the nearest metre, it says. So something's been rounded and it's ended up being 90. So it must have been closer to 90 than it was to 89 or 91. So if you imagine the 1 times table where each unit represents a metre, something like this, obviously 90 is what it's closer to. So to be closer to 90 than to 89, it must be over halfway in between 89 and 90. In the same way, if it's closer to 90 than it is to 91, it must be less than halfway in between 90 and 91. So it's got to be in between these two boundaries. So the absolute minimum it could be, yet still round up, would be 89.5 metres, and the absolute maximum point where it would actually tip over and round to the wrong point would be 90.5. So it's allowed to be 89.5, but strictly must be less than 90.5. So as an error interval, it needs to be in between these two values, and we write it in mathematical notation on the answer guide like this. The length is 89.5 upwards or including, but strictly less than 90.5 metres. Question 4 is about festivals. So festival A will be in a rectangular field with an area 80,000 square metres. The greatest number of people allowed to attend it is 425. So that's festival A, which I'm going to put in blue. Similar information for festival B, but we need to actually work out the area of that one. The greatest number of people for B is 6,750. I'm going to put this in red. It then mentions about the area per person allowed for each festival. So festival B has more area per person than the area per person allowed for festival A. So what does it mean by area per person? Or another way of saying that same question is, how do you work out the area per person? Well, if you imagine speed, miles per hour, to work out speed, you take the distance, miles, and then divide by what comes after the word per. It's the distance in miles divided by how many hours it takes. So think of the per as being a divider. So to work out the area per person, it's the area divided by how many people in each field. So let's just do this for festival A and then for festival B. So for A, the area per person is the area, 80,000, divided by the number of people, which is 425. And thank heavens this is a calculator paper, so that's what I'm going to suggest we use. So get your calculators ready. So 80,000 divided by 425, that gives us this, which is 188.2 of a person. Don't worry yet about that being an awkward number. Now for festival B, we need to work out the area first. Well, the area is a rectangular field, so we just simply do the length multiplied by the width, or the width times the length, either or. So 700 times 2,000. Use your calculator if you want to. In fact, it might be safer as long as you type in your zeros very carefully. So 700 multiplied by 2,000, and write the zeros down very carefully. 14 with 1, 2, 3, 4, 5 zeros after. That's 1,400,000. 14 with 5 zeros. So the area per person for B is 5 zeros, divided by 6750. So we take that figure we've just got, we divide by 6750, we press equals, press SROD, we get 207.4 to 1 decimal place at least. And that's how many people, area, sorry, per person. So I'm just going to call this very lazily area per person. And this one here is area per person. So area, what's it measured in? It's going to be measured in meters squared. So it's meters squared for that one and also meters squared for this one. So how much greater is the area per person for vestival B? Well, as you can say, 207.4 is bigger than 188.2. So how much greater? We do the bigger one, subtract the smaller. So 207.4 minus 188.2. And remember, we're rounding it to the nearest whole number. So we're going to do 207.4 minus off 188.2. That's about 19.2. And then we change that to the nearest whole number. And so essentially it's going to be 19 square meters more per person. That's the answer, so we can either underline that or whichever we need. Part B is about Callum's reasoning. So Callum says 300 square centimetres is the same as 3 metres squared because there's 100 centimetres in 1 metre, so you divide by 100. He's wrong. Explain why. Well, the clue here is the units. Centimetres squared means you multiply by centimetres in one direction and then multiply by centimetres in another. Normally for area, it's length by width. So because there's 100 centimetres in a metre, it'll be different by a factor of 100 in one direction and then different by a factor of another 100 in the other. So it's different by 100 and then 100 again. The scale factor difference is actually 100 squared. A nicer, probably easier way of putting this would be something like this. Simply, he needs to divide by 100 twice. I've put he needs to divide by 100, then divide by 100 again. In brackets, for a bit more clarity, he needs to change 2 dimensions by a factor of 100 because centimetres squared and metres squared are areas. 2 dimensions, so 2 changes, so 2 times he needs to divide by 100. Question 5. L, M and N are such that L, M, N is a straight line. So we're told that the coordinates of L, coordinates of M, so what you might need to do is just sketch on a coordinate grid. First of all, L is minus 3, 1, so let's sketch this in somewhere like so. 3 to the left of the origin, 1 up. M is 4 to the right of the origin and 9 up, somewhere about here. Now L, M and N are on a straight line, so there's going to be a straight line going through these points and a bit further up as well, something like this. Now we're told this ratio. The distance from L to M, this bit here, as a ratio of the distance from M to N, where N is somewhere up here, is 2 parts to 3 parts. So let's just think about this ratio in a bit more depth. N's going to be up here, and because it's 2 parts for LM to 3 parts for MN, obviously the distance MN needs to be greater than the distance from L to M. This is why I've made M to N a longer bit of the line. But importantly, we need to find the coordinates of N. So what does a ratio tell us? I always think of a ratio in terms of splitting things into equal parts. So L to M is 2 lots of a length, and M to N is 3 parts. So because we're going up, imagine it like a ladder. L to M is like 2 steps, and M to N is 3 steps. So literally, you could imagine this one in terms of steps. 2 steps going from L to M, where each step is equal to the other one, and M to N is 3 steps. So let's just work out how much each step must be. Well, the Y change is easier. We've gone from 1 to 9, which is a change of 8, and that's taken us 2 steps. So 8 upwards in 2 steps must mean that in each 1 step we're going 4 up. So 1 step we're going 4 upwards. The change in X, in 2 steps, 2 of these yellow steps, we've gone from minus 3 to 4, which is a change of 7. So we've gone 7 along in 2 steps, so 1 step will be half of 7, which is 3.5, or 3.5 if you'd prefer. So each step is 3.5 along and 4 up. So if we just continue that, another 3.5 along, another 4 up, another 3.5 along and 4 up, and so on, we'll then get to N. So then, n, we're at 4 plus 3.5 plus 3.5 plus another 3.5. So basically start at 4, then another 3 lots of 3.5 along. That gives us 14.5. You can leave it as a top-heavy fraction if you'd like. And in terms of the y-coordinate for n, at 9, we go another 4 up, 4 up, 4 up. So we go up 4 again 3 times. So 9 plus 4 plus 4 plus 4, or 9 plus 3 lots of 4, is 21. So the final coordinate for n must be 14.5 and then 21. Question 6 is about a new phone which costs £679. The value of the phone decreases at a rate of 4% per year, and we need to work out the value of the phone at the end of 3 years. So what I'd always suggest we do here in this scenario is think, what percentage of itself does an amount always start with before anything happens? So essentially, always remember that before anything happens to a value, it starts off as 100% of itself. So here we're talking about a decrease at a rate of 4% per year. So if 4% comes off the original 100%, that means that 96% remains. And 96% as a decimal, we can see as 0.96. And we can get the calculator to do this ourselves. So if we type in 96 and then find your percentage button on your calculator, shift answer button for mine, you get this fraction, press SROD, and you get 0.96. So this is called the decimal multiplier, and I'll explain why now. So essentially, this phone, we need to work out the value at the end of 3 years after it going down by 4% each year for those 3 years. So for the first year, we can just think that the £679 will become 96% of its former self. So we multiply by 0.96 to find the 4% reduction for 1 year. We do the same for the second year, so we multiply by 0.96 again for the second year, and you've probably guessed it, for the third year, we do the same. So in total, we do 679 multiplied by 0.96 to the power 3, and this power obviously relates directly to the number of years. If it were 6 years, it'd be power 6, and so on. So all that remains for us to do now is to work this out on our calculators. So 679 times 0.96 to the power 3, power buttons there, power 3, we get 600.735744 and so on. So this is a very long recurring answer, it would seem. So for this to have any meaning, we need to round this off to the nearest penny. So it looks like £600.73, but actually next to this 3 is a 5, which forces the 3 to round up to a 4. So to the nearest penny, we'd have £600.74. Question 7 is a unit conversion question, and we can do this in one of 2 ways. I'll show both methods here. So method A, we can do pounds per gallon. Method B, we can do euros per litre. So what is the question asking us? It's essentially, where is petrol the cheapest? So in Spain, Sam pays 27 euros for 18 litres of petrol, and in Wales, Leo pays £40.80 for 8 gallons of the same type of petrol. So we've got 2 different conversions here, one to change from euros to pounds, and the other to change from litres to gallons. Now we should notice here that both of these conversion factors are in the form where one number is a 1 and the other number is not a 1. So in terms of ratios, I know these are equal signs, but we can think of this as ratios in terms of this first one here being in the ratio 1 to n, and this one is in the form n to 1, where n is just some number apart from 1. So to change from one unit to the other, when our ratio is in this form, which these are, we just simply either multiply or divide by the number that isn't the 1. So in this case here, we're going to be multiplying or dividing by 0.85, and over here, to change from gallons to litres, we're going to be multiplying or dividing by 4.5. So which way round is it? Well, we can think of it fairly easily, actually. So thinking of the pound number here, 0.85 is a smaller number than 1. So we just pick any test number,
multiply it by 0.85 and see if it gives us a smaller answer, which it should do if our conversion from euros to pounds is correct. As long as you remember it's either multiplying or dividing by this factor here, you can't really go too far wrong. We'll just try a test value. And for litres to gallons or gallons to litres, we either multiply by 4.5 or divide by 4.5. So let's just think about this changing everything to pounds per gallon. So we need to think of Sam in Spain and Leo in Wales. So Sam in Spain is the yellow colour, Leo in Wales is the green colour. So Sam is paying 27 euros for 18 litres. So we can change the euros into pounds by multiplying by 0.85. So 27 times 0.85, that will tell us how many euros, apologies, how many pounds approximately he'd be spending. It'd be £22.95, and 18 divided by 4.5 gives 4. So he'd be spending, in terms of pounds and gallons, £22.95 for 4 gallons. We can then work out how much this is per gallon by doing 22.95 divided by 4. So if we divide that answer by 4, and then see what we get, round it to the nearest penny, we get £5.74. And so that means that essentially Sam is paying £5.74 per gallon. However, Leo gets £40.80 for 8 gallons. £40.80 divided by 8 comes out at £5.10 per gallon. So actually, the rate in Wales is cheaper than the rate in Spain. So Sam's thinking that it's actually cheaper in Spain than Wales, when actually it's the other way around, it's cheaper in Wales than in Spain. So therefore, petrol is cheaper in Wales than Spain, so you need to say Sam is wrong, or just is Sam correct? Clearly state no. Quickly showing you of a method, method B, where we're going euros per litre. So first of all, Leo's paying £40.80 for 8 gallons. We can change the pounds into euros by dividing the £40.80 by 0.85, and we can change the gallons to litres by multiplying the 8 by 4.5. That then gives us that Leo's paying 48 euros for 36 litres. So euros per litre, we can do 48 divided by 36, and that comes out to the nearest cent as €1.33 per litre. However, in Spain, Sam's getting 27 euros for 18 litres, and 27 divided by 18 comes out at €1.50 per litre. And again, doing the different conversion, you still see here that the cheaper rate is the price in Wales, €1.33, compared to the price in Spain, which is €1.50. The Spanish price is actually higher. So again, different conversions, but the same conclusion. Therefore, we state the same thing, and we need to say something like this, of course, again. So kept the wording exactly the same. Therefore, petrol is cheaper in Wales than Spain. So again, Sam is wrong. Question 8, a standard calculator question. Use your calculator to work out this thing here. This 3, if you notice, is smaller than the other digits. That's not a 3 at the front of a square root symbol. This means the cube root. So the first thing we need to hunt out for is the cube root. So on this particular Casio, which I highly recommend, you can press Shift, then the square root button here, which gives you the cube root button, which is a special function included in its own right. So now we need to do 1.57 to the power of 4, so power button 4, and then we're going to add on tan 60, so then we do plus tan 60, close brackets and press equals, and then what we can then do is divide that by 7.2 to the power of 1/2. So we get 0.739 to 3 significant figures. That's 0.739. You could have actually done this in just one go, in fact. I'll show you how to do it in one go right now. Ultimately, though, the answer is this. To do it in one step, what we'd do, because it's a fraction, you can type in the fraction button first, shift this to get the cube root, 1.57 to the power 4, plus tan 60, close brackets after, scroll down, 7.2 to the power, press fraction button there, 1/2, and you'd see, yet again, you get the same solution, just a slightly quicker way, 0.739, whichever way around you happen to go with that one. Question 9, we've got a box in the shape of a cuboid which is placed on a horizontal floor. So the box exerts a force of 180 newtons on the floor, and also the box exerts a pressure of 187.5 newtons per square metre on the floor. The face in contact with the floor is a rectangle of length 1.2 metres and width x metres. Work out the value of x. So let's just unpick this one step by step. So face in contact with the floor is a rectangle. So let's just picture a box with a rectangular face sitting upon a floor. So it's going to look something like this. So length 1.2 metres and width x. So we can picture a box looking like this. So the area in contact with the floor is this half-dotted rectangle, which I've just added in here in red. So it exerts a force of 180 newtons on the floor of this box, so we know the force, and we're also told the pressure it exerts, so we know the pressure is 187.5 newtons. We can then use this formula to work out the area which is actually in contact with the floor. So we can either rearrange this formula if we want to, or you can use the magic pressure, force, area triangle like follows, just to see what the area would be by covering up what you want to know. So rearranging the formulas is a much better method. You need to know how to do that for harder formulas. But for simpler formulas like this, where it relates to three things in a triangle, cover up the thing you want to know. I want to work out the area in contact with the floor, which is A. So if I cover up A is F over P. So let's work out what the area in contact with the floor is. So area is the force divided by the pressure it's exerting. The force is 180, which we were told, and also the pressure is 187.5. So if we work out this now, using the calculator, so we've got 180 on top and 187.5 on the bottom. We get 24 over 25, which is 0.96. So the area must be 0.96 square metres. But we're told that the area, which is 0.96 metres, must be made up of a length which is 1.2 times x. So therefore we know for this 0.96, which is the area of a rectangle which is in contact with the floor, must be the same as the area, well, of a rectangle, which is 1.2 times x. So 0.96 equals 1.2 times x, where x is the width we're trying to find. So we can rearrange this formula by dividing both sides by 1.2 to isolate x and get what x is on its own, which is what we want to do because x is the width. So therefore, x equals 0.96 divided by 1.2. So take this, divide by 1.2, and we see that the width must be 0.8 metres. So x is 0.8 or 0.8 metres. Question 10, we have a box plot showing information about the sales in thousands of pounds of an online store each month. Andrew says 3/4 of the given data lies between 160,000, which he's actually right, and 350,000, again true, because these are the values of the lower and upper quartile. So the lower quartile is what he says, and the upper is what he says. So he's wrong, explain why. It's actually this part of his sentence, it's the initial bit. Between the lower and upper quartile, that tells you your middle half of the data. So not 3/4 in between the lower and upper, but 2/4, in other words, a half. So you could say something like this in terms of why he is wrong. He's wrong because 2/4 of the data lies in between the lower and upper, not 3/4 like he's saying. So he's wrong by a quarter. That's probably the easiest way of explaining why Andrew isn't quite right. Question 11, we've got a table showing information about the sales in thousands of pounds in a shop each month. Just double check what we've got here. If we're drawing a box plot, we need 5 pieces of information. We need the lowest value, we've got that. The greatest value, yep. The lower and upper quartile, we've got those. And also the median. So we can safely plot these 5 points. What examiners sometimes do is to give you 5 values which aren't these particular 5. For example, we might throw in the range, or the interquartile range, and see if you fall for the trap of plotting that. But the 5 things you need to plot each time are least, lower quartile, median, upper quartile, and greatest value. So we can just add these in along the axis here, the x-axis. So 30 goes here, 80, 170, 260, and 350. So these 5 points are where we put our 5 vertical lines like so. Then we make the box by joining the second and fourth line together at the top and the bottom, and the whiskers join in between the first and second line and the fourth to the fifth like so. So that's our completed box plot for sales in the shop. Part B, we're asked to compare the distribution of sales on the online store with the distribution of sales in the shop. So let's just get our 2 box plots together so we can compare and contrast. So online store at the top and shop at the bottom. When comparing distributions in terms of box plots, always compare the 2 same things each and every time. So you need to be comparing always the medians and also the interquartile ranges. You can actually get away with comparing the ranges instead of the interquartile ranges, but it's much better to be comparing the interquartile ranges. So first of all, the medians. The median is represented by this middle line in the box plot. Not necessarily in the middle of the box, but a line somewhere within the box. So the online store has a median of 200,000, because it's sales in thousands, and the shop has a median of 170,000. Comparing the interquartile ranges is the upper quartile, the end of the box, minus the lower quartile, the beginning of the box. Essentially as well, you can think of the interquartile range as being the length of the box in the middle. So the online store has an interquartile range of 190,000, the shop has an interquartile range of 180,000. You need to compare the medians and the interquartile ranges in context. The median relates to sort of like a typical figure, or you could say like on average, something like this. So the higher the median, the higher the average sale. Comparing the interquartile ranges, the interquartile range gives a measure of spread. The lower the interquartile range is, the more consistent the data is. So we could say something like this, making reference to the context. So on average, or typically, sales from the online store tended to be greater than sales from the shop, because the online store has a higher median, 200,000, versus the shop's median of 170. Second comparison about the ranges, interquartile ranges, but the shop's monthly sales were more consistent, because the shop's monthly sales had a smaller interquartile range of 180k versus 190,000, and the smaller the interquartile range is, that shows that the data is therefore more consistent. Question 11. Kieron has 13 workers he can use for a job. He knows that 6 workers would take 14.5 days to complete this particular job. Show that Kieron has enough workers to finish this job in less than 7 days. So let's start with this middle bit here. He knows that 6 workers would take 14.5 days to complete this job. So let's imagine 6 people working as hard as they realistically can for 14.5 days each. So imagine these 6 workers going at it. Each one's been working for 14.5 days. So how much work in total is that equivalent of for just one person doing all the work? Well, 14.5 days times 6 people is the same as 87 hours worth of work. But if Kieron's got actually 13 workers he can use, rather than having that 87 hours worth of work divided by 6 people, he can share this 87 hours worth of work in between 13 people, thereby reducing the number of days each worker needs to work. So what's 87 divided by 13? Well, 87 shared between 13 is 87 divided by 13, which, if you do it on your calculator, is about 6.69 hours worth of work each. So just over 6.5 hours worth of work. We needed to show that Kieron has enough workers to finish the job in less than 7 days. 6.69 is less than 7, so yes, actually he can finish that job within 7 days. Question 12, we have an equation of 2 lines. The equation of line L1 is y equals 2x plus 3. The equation of L2 is 5y minus 10x plus 4 equals 0. Show that the 2 lines are parallel. What we need to do here is to show that the gradients are the same for each. So for L1, we can see here it's y equals 2x plus 3. So the gradient, m, of L1 equals 2. Now L2 is in this strange form. The best form to write a straight line is y equals mx plus c. Right now, this straight line is not in that particular form. So what we need is y on its own. We need y as a subject. So what we could do as our first decision, perhaps, is to add 10x to both sides. So if we do that, what we're going to end up with is 5y on one side. We've not touched that plus 4, so leave the plus 4 alone. And on this side, we've got 10x. To get rid of the plus 4, we can subtract 4 from both sides. So if we do that next, we're going to have 5y equals 10x minus 4. And then finally, to go from 5y's down to just 1y, we can divide by 5 on both sides, of course. So therefore, we know that L2 is the same thing as y equals 10x divided by 5 is 2x, and minus 4 divided by 5, you can leave as either minus 0.8, or just leave it as 4/5. But importantly, the coefficient, the number in front of the x, when L2 is in the form y equals, is also 2. So therefore, the gradient of L2, which is also the gradient of L1 from before, almost ran out of space. I do this all the time, it's very annoying, I need to learn. But the gradient is also 2. Then we can just conclude by saying something like this. Therefore, since L1 and L2 both have a gradient of 2, they are parallel, because all we need to show if two lines are parallel is that they have the same gradients. They are, because they both have a gradient of 2. So something just to conclude your results, you need to show that they've both got a gradient of 2, then just a little sentence here concluding that that shows that because the gradients are the same, they must be parallel. Question 13, enlarge the shaded shape by scale factor -2 with centre of enlargement 0, 0. So the key thing is the centre of enlargement. 0, 0 is the origin, so I'm just going to plot this in with a big fat X like so. There's a few different ways you can think about enlarging a shape. Importantly here, the scale factor of this one's -2, so I'm going to mention the importance of this negative in a second. But what we need to do is consider that the size of this shape is going to change, hence it's called an enlargement. It's not necessarily going to get bigger, it could get bigger or smaller. But what we should do first is to just label on or colour in each of the vertices, each corner of the original shape. So I've just gone for a black dot, red dot, green and blue. Now what we could decide to do is to do a straight line from the centre of enlargement going through each of these points and extending beyond as well. As well as extending beyond, we can also do a straight line going through the centre of enlargement and going back again, something like this. So the blue line and the red line for the blue dot and red dot overlap. That's why I've done the blue in a dotted line, so you can see the red and the blue are along the same line. The green dot has a green line going through the centre of enlargement and the black line as well. So now, importantly, the scale factor is -2. The scale factor tells you how much bigger the original shape is going to become. Because the size of the number is 2, the shape's going to be doubled, but because it's a minus, what this means is the shape is going to end up being behind the centre of enlargement. So essentially, each point is going to become twice as far away from the centre of enlargement. That's another thing to consider. But it's going to appear behind the centre of enlargement. That's because it's a negative scale factor. I apologise for the typo. That should be an E there. I just spotted that. How annoying. But I'm going to leave it on there because, you know, I'm human. But maths and English both matter. That should be an E. So I'm going to slap myself on the wrist. Anyhow. So, this point here, the black, it was 5 to the left and 2 down. So if I double those distances, it's going to be 10 to the right and 4 up. So from the red cross to the black line, that distance on the other side is going to be doubled, but it's going to be behind the centre of enlargement. This red point, was 3 to the left and 2 down. If I double those distances, we're going to have 6 to the right and 4 up. So the red point's going to end up here. For green was 2 left, 4 down. If I double those distances, we're going to have 4 right and 8 up. Like so. And finally, the blue point will end up being transformed to here. Once you've got your points, we then just join them up with a straight line to form the trapezium and colour it in so that you can clearly show your enlarged shape on the grid to the examiner, something like this. You can also consider it using vectors in terms of how far away each point is from the centre of enlargement. So considering a vector method, which I'm going to touch on very, very briefly here, the vector method considers the positions of the points relative to the centre of enlargement. So if I just pick, for example, and you can read this yourselves if you want to pause the video, the black dot, relative to the centre of enlargement, that was 5 to the left and 2 down. Minus 5, minus 2 as a column vector. So the black point as a column vector position is minus 5, minus 2. The idea here is you can think of this column vector being multiplied by the scale factor. So I'll just do it for the black points. You can convince yourself for the others. If I multiply both these values by minus 2, I'd end up with 10, and minus 2 times minus 2 becomes 4. So rather than being 5 to the left and 2 down, relative to centre of enlargement, the black point, once it's been transformed, should be 10 to the right and 4 up, which indeed it was. So that's just a different way you could consider enlarging shapes, whether it be with a negative scale factor or indeed a positive one. This vector method is very powerful. Question 14. Saffron wants to work out an estimate for the total number of fish in a lake. So on Friday, Saffron catches 180 fish from this lake, and she puts a tag on each of these fish and then puts them back into the lake, so then mix up amongst all the other fish. Then on Saturday, she catches 305 fish from that same lake and finds that 45 of those 305 fish she's just caught for the second time are tagged. Work out an estimate for the total number of fish in the lake. There's a key thing you need to know about this idea, which is called capture and recapture. So essentially, she captures some fish, releases them, then recaptures. The idea is as follows. So the capture and recapture key concept is that the fraction of items tagged or caught or painted, whatever, in the recaptured sample must be approximately the same as the fraction of the entire population that was tagged to begin with. So how many fish did she tag to begin with? Well, she tagged 180 fish. And after, when she recaptures them, she finds that 45 of the 305 fish are tagged. So as a percentage, or as a fraction, what's that? So 45 out of 305, what does that give us? So 45 divided by 305, as a fraction is this, as a decimal it's that, so as a percentage, if you wanted to do it as a percentage, you don't have to, about 14.75% of the fish. So she's caught, well, she's tagged approximately 14.75% of the fish. So that's the conclusion we make. Because 14.75%-ish of fish are tagged, that's our way into the question. So therefore, we'd expect that the 180 fish she did tag must be 14.75% of the population. So that's 14.75% of the fish. So then we can work out how many fish must be 1%. To go from 14.75 down to just 1%, we can divide by that amount. So if we divide both sides by 14.75, so 180 divided by our answer, essentially, gives us 12.2 fish. Then finally multiply by 100 to get 100%. So 12.2 times 100, as you can probably do without a calculator in fairness, about 1,220 fish in the lake. is our estimate. So essentially it's just scaling up fractions of amounts. That's all we're doing. Question 15 is a fairly nasty ratio question in my opinion. We've got a ratio of Marta's hourly pay to Khalid's hourly pay, which used to be 6 lots to 5 lots. So ratios often work as fractions. So I'm just going to first of all write this down as a fraction. So Marta's to Khalid's used to be 6 lots compared to 5 lots. So 6 lots, where lots is just my informal way of expressing what an amount happens to be, over 5 lots. So 6 lots for Marta compared to 5 lots for Khalid. But they then get the same exact rate of increase. They both get an increase of £1.50. So they both get added on an extra £1.50 to their rates. And that then takes their ratio after they have this increase to 13 to 11. So 6 lots plus 150 as a ratio of 5 lots plus 150 takes them to an overall ratio of 13 lots, new lots, to whatever 11 new lots is. But because this might be 13 bits, not to confuse it with lots, over 11 bits, it'd cancel, it'd be unitless, it'd still be 13 elevenths as a fraction. So what I'm going to do here is just convert this into a formula to solve. So whatever 6 lots are, or 5 lots are, I'll just call a lot L. So 6L plus £1.50 all over 5L plus £1.50 obviously goes down to a ratio of 13 to 11. So you've got one fraction equaling another, and we need to solve them. So the best way I think of solving one fraction and equaling another is to cross multiply. So this numerator times the opposite denominator will equal this numerator multiplied by the first denominator. So that is one way of solving it. So then the next step, 11 times 6L plus 1.5 must equal will equal 13 times 5L plus 1.5. So we can then expand both these brackets. So 11 times 6L gives 66L. 11 multiplied by 1.5. Best thing would be to use a calculator, I would imagine. So 11 times 1.5 will give you 16.5, but let's try it just to make absolutely sure, because it is a calculator paper, and it'd be silly not to use it. So it'll 66L plus 16.5. Expanding that one like so, must equal 13 times 5L. 13 times 5L gives us 65L. And then 13 multiplied by 1.5 will give us 19.5. Now, we need to get all the L's onto one side of the equation. So what I'm going to suggest we do is just to simply subtract 65L from both sides. And then over here we'll just have 1L plus 16.5 equals 19.5. Therefore, if we finally subtract 16.5 from both sides, we see that the original amount must have been that each lot was 3. So the hourly rate of pay before the increase for Marta and Khalid, so Marta and Khalid, they've had 6 lots to 5 lots. Marta must have had 6 lots of 3, which is £18. And Khalid must have had 5 lots of 3, which is £15. And that, therefore, must have been their hourly rates before the £1.50 increase. Question 16, we have a 3-way Venn diagram. A shop manager wanting to advertise special offers on social media platforms, A, B or C are the platforms. With 3-way Venn diagrams, you have to start from the biggest overlapping section first, where they all overlap together. So are we told how many people use both A, B and C? Well, fortunately, yes we are. 4 people use all 3 types, so 4 out of 100 goes bang in the middle here. Next, we're told that 16 don't use any of type A, type B, or type C. So 16 people out of these 100 don't belong in any of these circles, so they go and be outside of the circles but within the square or rectangle, so those 16 people need to go somewhere on the outside, like so. Next, we're told 8 people use both type A and B, but not type C. So if you use A and B, it's going to be in this middle bit, but if they're not using type C, that restricts these 8 people to just this section here, between A and B, but not the yellow bit. So these 8 people must go there. Next, we're told that 14 people use both type B and C. For people using both B and C, is this eyelet here, including this 4. So if I highlight this one in green, like so, we know from this piece of information 14 people need to belong in this bit. So we've got 4 already out of these 14. So we need an extra 10. These extra 10 must go in this section, therefore. We're then told 62 people in total use type A. So the total in the circle A needs to be 62. So in here needs to be 62 people. I've got 8 plus 4, which is 12 so far. So the other 50 need to go either here or there, or a combination. I don't know enough information yet, so I'm not going to tackle this region yet. So let's move on to the last part, which is all 20 people who use type C also use at least either A or B. So all 20 people using C must belong in either the A section, B, or both. So the people in C must all be overlapping with A, B, or A and B, somewhere in this purple region like so. So as you can see, we've got 4 plus 10, which is 14 people already in this purple region. There must be 20 in total. 4 plus 10 is 14, so the other 6 must go here in this region of circle A. So now in circle A, we can see we've got 8 plus 4 plus 6 people, which is a total of 18 people so far. But we know in grand total for circle A there needs to be 62. So in this region of circle A, we can do the 62 in total it needs to be, and subtract away that 8, that 4, and that 6. So we know there must be 44 people, therefore, in this region of circle A. Finally, we need to work out how many people go here for circle B. Well, there's 100 people in total, so 100 minus all of these numbers will therefore be how many people are in this region of that circle B. So if we do 100, take away the 44, take away 8, take away 4, take away 6, and take away 10, we get 28 people. And then, of course, don't forget the 16 as well. That could be quite damaging if we've got that. So take away 16, that gives us 12. So you have 12 people going this part here of circle B. And that's the Venn diagram completed. Then for part B, we're told one of the customers is chosen at random. But then we're told, given that this customer chooses type A, find the probability that this customer also chooses type B. So if this customer chooses type A, it could be any one of these here. It could be any one of these 62 customers who use type A. So the probability that they also use type B, well, out of these 62 customers, how many use type B? Type B is this region here. So we've got 8 and this 4. 8 plus 4 is 12 out of 62. You can simplify that if you really want to. Use a calculator, you may as well. So 12 over 62 becomes 6 over 31. But you don't need to simplify it because it's probability. So 12 over 62 or 6 over 31. Question 17, we're talking about volumes of a compound shape. So we have a solid cone, which is joined to a solid hemisphere, which is this bit below, to make a solid they've called capital T, which is basically a cone stacked on top of half of a sphere, a hemisphere. So we're told the diameter of the base of the cone is 7, and also that the diameter of the hemisphere is 7, so it fits exactly on top of one another like so.
Total volume of the shape is 120 pi. The total height of it is just given as y centimetres. Calculate the value of y, give your answer correct to 3 significant figures. Well, here we can see the examiner's been slightly nicer than they had to be. We've got some formulae to work with. So we've got volume of a sphere, which is 4/3 pi r cubed. So actually what we could do is just slightly adapt that to work out the volume of a hemisphere. So if I just change this to hemisphere, hemisphere just means half. So if a full sphere is 4/3, then half of it, the hemisphere, will be 2/3 pi r cubed. So we can just make that edit easily enough. So the total volume of T will be 2/3 pi r cubed plus 1/3 pi r squared h. So here we can see the diameter is 7, and it does say the diameter is 7 in both of these parts. So therefore the radius must be half of that, which is 3.5. So then just using these formulae, we can say that the volume of T, let's call it VT, equals 2/3 of pi r squared. So that's 2/3 pi times radius, 3.5 squared. Sorry, 3.5 cubed, what am I talking about? Then plus the volume of a cone, which is 1/3 pi times radius again, which is 3.5, this time squared, multiplied by the height of the cone, which we're just going to call h. So h, of course, is the height of just the cone. It's not the same as y. H is just the cone, which is this bit here. So I'll move that line so it's out of the way and just label that h. And we got the 3.5 from the idea that the radius is 3.5. And also we're told that the volume is 120. So we can equate this and just say this volume must equal 120. And we've got an equation from which we can work out this value of h. So 2/3 pi times 3.5 cubed. Let's work that one out. So 2/3 times pi. So then we do shift this button here on this calculator times 3.5 cubed. That gives us 343 over 12 pi. Then plus all this bit of h, so 1/3 pi times 3.5 squared. So let's just type this exactly as it says. So 1/3 times pi times 3.5 squared. 49 over 12 pi. In fact, I'll just give this as a decimal. 12.82817. So we've got that many lots of h. 12.82817 equals 120. So we can now rearrange this by taking away this 343 over 12 pi from both sides. That wasn't the colour I wanted. So take it from that side and the other side. So that then gives us that 12.82817 lots of h is 120 minus 343 over 12 pi. So 120 shift pi. But we're going to subtract away, what was it? Yeah, 343 over 12 pi. And that should give us a value of this, which is a decimal is about 287.193 and so on. And the final step, to get h on its own, we can just divide both sides by the coefficient of h, this 12.82817 value. So divide by 12.82817 on both sides. We can then see that therefore h must equal this divided by 12.82817. So let's see what it gives us, and this is going to be our answer, at least for h. H is 22.388. 22.388. But of course we want to find what y is. So therefore y, which is h plus this bit here, which is an extra 3.5, because that's a radius below. So 3.5 plus h is the total y, so h plus 3.5, in other words, our answer we've just worked out, add 3.5 to it and round it to three different figures. So that gives us 25.9 cm. So the height of this shape is 25.9 centimetres. Part B is then saying that the diameter of the base of the cone and the diameter of the hemisphere are both increased. So this shape gets wider. This is what it's like currently. So it's going to go from looking something like this to something which is wider like this. So if the height stayed the same, which I've tried to show in these sketches, clearly the volume of the wider one is greater than the volume of the original. But it does say that the volume doesn't change. So if it's made wider, that would increase the volume. So the only way to balance it back out again is if it's made a bit stumpier, a bit shorter, something like that. So actually, if the volume hasn't changed, but it's got wider, the height must have decreased to make it still balance back out again. So simply put, explain the effect this should have on your answer to part A, which is the height, y. You just need to say something like it would decrease. Simple as that, and that'll pick up your mark. Question 18. PQR and QRS are triangles. Little word of caution here, these aren't right-angled triangles, so we might be using the sine and cosine rule. And again, look at the question number, we're towards the back of the paper, it's not going to be standard trig. It might, but unlikely. We need to calculate the length of QS. So if I just highlight in purple QS, which is this line here, and as well what I'd always say to students, if you can work something out, which seems obvious, just do that. So QRS, we've got two angles in a triangle here. We can therefore work out the third one, because angles in a triangle add up to 180. So this angle at Q would be 180 minus 88 minus 41. So let's just work that one out. So 180 minus 88 minus 41. That gives us 51 degrees. So we can label this one in. However, this triangle here, QRS, we only know the angles, we don't know any sides at all. So right now we can't really work out anything else on this triangle QRS. Let's therefore ignore this triangle and focus on this top one, PQR. Now, PQR, we know two sides either side of the angle which is enclosed by these two sides. So this is a hint that we might be able to use the cosine rule. If we've got an angle and know two sides either side of that angle, we can work out the third side by using the cosine rule, which you need to remember goes something like this. So I need to label the side I'm trying to find as A, and the angle opposite to it, big A, and the cosine rule, like I've been saying, label B and C, the other sides. We can then use this. A squared equals B squared plus C squared, where B and C are the other sides in any order, minus 2 lots of B times C times the cosine of the angle opposite to the side you're wanting to find. So I've done the side in red that I'm trying to find, and the other sides, which I do know, in green and blue. So just sticking with that colour coding here and plugging in these values, we see that the A squared needs to equal 11 squared plus 9.4 squared minus 2 times 11 times 9.4 times cos 27. So we can work out this horrible thing now on our calculator to find what A squared must be. So that's 11 squared plus 9.4 squared minus 2 times 11 times 9.4 multiplied by cosine of 27 and close off the brackets. That gives us 25.0998508. Now we can square root both sides to work out what A is. So if I just square root this answer here, square root A and S, we get that side A is 5.0099 and so on. So that's what A is. We can now add that to our triangle PQR. Now we've got the side QR, we can then return to thinking about the triangle below here, which was QRS, like so. Now for QRS, we want to work out side QS, we know the angle opposite to it, and we also know another angle and opposite side pair. So if you want to know a side or an angle, and you know a pair of side and opposite angles, then you can use the sine rule. So just reminding you what the sine rule is, we've got this. A over sine A equals B over sine B equals C over sine C, where little a and big A are a side and opposite angle respectively, same with little b and big B, same with little c and big C. We only need two pairings. So if I just focus on the A and sine A and B and sine B, A and sine A could be these two pairings of 5.00 and the 41 degrees, and B over sine B, I can think of the little b as QS, which I'm trying to find, which would make therefore big B the angle opposite to it, which would be 88. So just plugging these values into the sine rule equation, we'd get this. So we can work out what the length of QS is by simply multiplying both sides of this by sine 88. And that's our final step. So therefore QS equals 5.0099, can't be bothered typing it all out, over sine 41 times sine 88. So let's see what this gives us. So we've got the 5.099 and so on. I need to do that answer over sine 41 and then multiply that by sine of 88. And you should get to three significant figures, 7.63. So the final answer to this one is 7.63 centimetres, rounded to three significant figures. Quite a challenging question, but they do get challenging when you get to the stage of the paper. So that's question 18 done. Question 19, we're talking about functions. So g and h are such that g of x is the cube root of 2x minus 5, and h of x is a reciprocal of 1 over x. First of all, part A, find g of 16. So all this means is what we're inputting into the g function is 16, whereas normally in a general way we input x, our x value here is actually going to be 16. So we're just substituting in 16 in place of x. So therefore g of 16 is the cube root of not two x's but two 16s minus 5. Just by substituting in, like I've said, that 16 is our x. So we can do this on a calculator. In fact, I'd recommend you do it since it's calculator paper, but I'll just show you here that you don't need to, strictly speaking, for this one. 2 times 16 is 32. 32 take away 5 is 27. And hopefully you should remember that 27 is a cube number. So the cube root of 27, the number which, if you times it by itself 3 times, which gives you 27, is 3, because 3 cubed is 27. So the first one, part A, g of 16 is 3. Part B is quite a bit harder. Find h g minus 1 of x. So first of all, it's a compound function, it's composite, and also it includes an inverse. G minus 1x is the inverse. So what I'm going to do here is just let y equal g of x. So if I just call y g of x for first of all. So I can say that y is the cube root of 2x minus 5. To work out what the inverse is, my goal, first of all, is to make x the subject. So what I need to do here, to get x on its own, to undo this cube rooting, I need to cube both sides. So on the left, we get y cubed, and if you cube the cube root, it undoes the cube root, and you're just left with what's inside the radical, which is just a fancy word for the square root symbol. We'll just get 2x minus 5. Like I say, the goal is to have x on its own, so next I need to add 5 to both sides, which gives us that y cubed plus 5 is 2x. Therefore, divide both sides by 2. That gives us that therefore x equals y cubed plus 5 all over 2. Now what we do is we just switch around what x and y are. So we replace x with g minus 1 of x, and we just replace letter y with x. So g minus 1 of x is x cubed plus 5 all over 2. So that's our basis for now launching in and finding what h g minus 1 of x is. So therefore, h g minus 1 of x is h of whatever g minus 1 of x is. So it's h of x cubed plus 5 over 2. So what does h do to the function? H turns the function on its head. So essentially, it writes it as 1 over what it was. So 1 over x is the reciprocal of x. All that means is the fraction gets turned on its head. So this here, instead of x cubed plus 5 over 2, it becomes now with the 2 on top and the x cubed plus 5 on the bottom. So our answer is that hg minus 1 of x is 2 over x cubed plus 5. Question 20. A, B, C and D are points on the circumference of a circle, centre 0. A, D, E and B, C are straight lines. Work out the size of angle CDE. Give a reason for each stage of your working. This is where circle theorems revision comes in handy. So first of all, what is the angle we're trying to find? Angle CDE is this one here, so we're going to highlight this one in yellow. And step by step, we need to start thinking about what circle theorems we can use. Well, the first thing I'd notice is this 132-degree angle here. And I always think of this as like a rocket shape. So if we have two radii joining the circumference to the centre, then on the other side, and this sort of triangle makes another one here, by rocket, I'll just explain what I mean. In my very silly mind, it's like a big arrow. So in my brain, what I'm thinking is the point at this end of the arrow is always double the size of the angle down here. So essentially you can think of it as the angle at the circumference is half of the angle at the centre, or the angle at the centre is double the angle at the circumference. That's the circle theorem we use. In plain English, this angle here is just half of the angle at the centre. So half of 132 is 66. So this green one is 66, and we need to give that reason why we know that. So what we could say is BAD equals 66 degrees, and the circle theorem we're using there is the angle at the centre is twice the angle of the circumference. You could say it the other way around, like I've said, and just say the angle at the circumference is half the angle at the centre. Potato, potato, whichever way around. So that's all well and good. That's 66 degrees. And what you need to notice as well, if I just do a line from A to D, from D to C, C to B, and B to A, it's a four-sided shape with all 4 points on the edge of the circumference. It's therefore not just a quadrilateral, because it's four-sided, it's a cyclic quadrilateral, because all 4 sides lie on the circumference. So what do you remember about cyclic quadrilaterals? You need to remember that the opposite angles in a cyclic quadrilateral add up to 180. So if that's 66, the angle opposite to it, this one here, will be 180 minus 66, which is 114. So this one I'm going to highlight in purple is 114, and we give a reason like I've just said. Something like BCD is 114 degrees, because angles in a cyclic quadrilateral add up to 180. We're not too far from home now. So just going back to what it says here, BCE is a straight line. So from B to C to E is a straight line. If that's 114 degrees, you need to remember that angles on a straight line add up to 180. So this one plus this one here will add to 180. So this bit will just be 180 minus 114, which will be 66 degrees. So we can add on this pink one as being 66 degrees, because angles on a straight line add up to 180. And putting these reasons in is crucial for picking up all the marks. So that's 66 degrees. We want to find angle CDE. So if we just ignore everything else and focus in on this triangle now, you can see that we know 2 of the 3 angles in this triangle. Angles in a triangle, you probably knew from year 7, add up to 180 degrees, so we can finally work out the size of angle CDE by doing 180, take away 66, take away 16, which gives us 98. So the final step is just to say that CDE is 180 minus 66 minus this one I've colored in red, which is 16, which is 98 degrees. And again, give the reason for that as well. Give every single reason you can think of. Angles in a triangle add up to 180. So that's all we need to put. That's question 20 sorted out. 21, we've got the graph of f of x on the grid, and then we want to show on the grid above the graph of f of minus x. So the change from f of x to f of minus x is inside the brackets, so it affects the x coordinates only. And we need to think of this minus x as being like a minus 1x. So inside the brackets works as opposite to what you'd expect. So it looks like the x values are going to be multiplied by minus 1, whereas actually we're going to be divided by minus 1, which actually doesn't make much difference because it's minus 1. If it were minus 2 or minus 3 it would, but essentially these x values are going to be multiplied by minus 1. So for example here, where x was minus 1, that'll get translated to where x was minus 1, which is 1. Where x is positive, for example here x is 2, that'll become x of minus 2. So each point is going to be mirrored in the y-axis. Long story cut short, f of x to f of minus x is always a reflection of a function in the y-axis. So what we need to do here is to mark on the points which are clearly going through the squares, which we can use to help us. Add on the axis of symmetry. The points I was saying, I think are these ones. So if we just flip these in the y-axis, which I've highlighted in the dotted green, I've highlighted them in blue dots, and just try and get a smooth curve like the original one is, going through these points like so. So something like this. That's the graph of y equals f of minus x. Just a reflection of the original in the y-axis. Question 21, we've got a sketch of a graph of y equals tan x. So the graph of tan x is translated to give a graph of gx. So following the translation, the point Q, which is here, moves to the point R. R has coordinates 90 and minus 5. Find an expression for g of x in terms of x. We need to know a bit more information about the graph of tan. And what helps here is knowing certain values of tan. Now you can use your calculator if you want, or you can recall these values from the exact trig ratios. But tan of 90, that's where it goes up towards infinity. It never quite touches because infinity isn't actually a number, but this is where it becomes undefined. So we can actually add on the coordinates to help us. That must be 90. So from touching the axis to going to this asymptote is a 90-degree gap. So from there to there's 90 degrees, and by symmetry from here to this bit's also 90. So each weird S shape has a difference on the x-axis of 180 degrees. In fancy language, if you do A-level maths, the period of tan x, basically how many degrees you need to go through till it does one complete cycle, is 180. So 90 plus 180 is 270, plus another 180, that's 450, and so on. So Q is actually at the point of x being 360. So Q is at 360, 0. It now moves to R, where R has coordinates of 90 and minus 5. So 90 for x is here, and minus 5, probably something like this. So it goes from 360, 0 to 90 minus 5. So let's just think about what's actually happening to this point Q. So to go from 360, 0 to 90, 5, going back and then going down. That contrast isn't very good, so I'll change the colour to a brighter green. That looks better. So to go from 360 on the x-axis to 90, we need to go 270 degrees to the left, so 270 to the left. So the x values are being affected, and then also the y values need to go down by 5, so we need to go 5 down. Now we want to find an expression for g of x, the translated curve in terms of x. So we start off with y equals tan x. Now the x values need to move 270 to the left. So what we need to do first of all is to change it from tan x to tan of x with some 270 involved. Now it's tempting to think because we're moving to the left, we're knocking 270 off the x values. But remember, inside the brackets works opposite to common sense with x. So we're going to actually do x plus 270. So because it's inside the brackets, that has the effect of knocking 270 off the x values, which is what's happened because we've done 360 minus 270 to get to 90 degrees. That's not enough though, that only takes us to this point here. We then need to go down 5, so we need to affect the y values by moving them 5 lower. So we take what we've got already, which has affected the x values, which we want, and we need to affect the y values by moving down by 5. To affect the y values, we make the change outside of these brackets, and we apply it in a common sense sort of way. We need to knock 5 off the y values, so literally just knock 5 off. So that's what g of x is. So in other words, g of x is the original tan x graph plus 270, so we move 270 to the left for x, then minus 5 units to make the y coordinates 5 lower, which is what they need to be. Question 22, the very last one on the paper. So find algebraically the set of values of x for which x squared minus 49 is greater than 0 and 5x squared minus 31x minus 72 is also greater than 0. To solve inequalities which are quadratic, whether it be two sets like these or just one, I'd always suggest to sketch a grid out. Sketch axes and then do a sketch of a quadratic. So we've got x squared minus 49, which I'll do in red, and this one here, which looks much harder, I'll do this one in blue. So here's the grid. So first of all, let's just think about this not being greater than 0, but being equal to 0. So x squared minus 49 equals 0, if you like. Now this one here is actually a difference of 2 squares. So 49 is a square number, and x squared is literally x squared. So we can write this as x plus 7, x minus 7 equals 0, like so. And therefore, the critical values are x equals 7 and x equals minus 7. So what I'm going to do here, I'm actually just going to put this out of the way so we're not going to get in the way of what I'm going to show you here. So if I just pop this down at this side, we can think of plotting this on. So x squared minus 49, the coefficient of x squared is positive. It's a positive x squared, not a negative, so it's going to be a happy parabola. And it's going to cross the axes at 7 and minus 7 for x. So if I just get these x-axis points labelled on, like so, then it's going to cross at minus 7 here and 7 there. And before I just add these on, I'm just going to draw in a graph with a line on it so we can represent these inequality solutions on a number line. But first of all, if I just take this here and then just add on the sketch, so like I said, it's going to cross at minus 7 and 7, we can therefore see that the solutions where this is greater than 0, it's higher than the x-axis, where y is positive, where x is less than minus 7, and also it's greater than 0 when x is greater than positive 7. So the first thing that we can add on is the values of x which satisfy this inequality in red. So x is either less than minus 7 or x is greater than 7. This one here, 5x squared minus 31x minus 72, we could either A, factorise that, it will factorise, or what I'd suggest, because it's a calculator paper, we can actually use this thing here, the quadratic formula. So if we just substitute in these values here, so x is going to equal minus b minus 31, which is plus 31, plus or minus the square root of b squared, so minus 31 all squared, minus 4 times a, which is 5, times c, which is minus 72, all divided by 2 lots of a, which is 2 times 5. So if we just bang this into our calculator, so 31 plus the square root of minus 31 in brackets all squared, minus 4 times 5 times minus 72, all of that divided by 2 times 5, we get 8. And also, if I change this to a negative for the minus square root option, so if I just toggle back here, I can delete that plus, change to a minus. We've got minus 9 over 5, which is minus 1.8. So again, the x squared coefficient is positive. So this one here, like we had for the graph of the x squared minus 49, just mind you go this one, 5x squared minus 31x minus 72 will also be a positive curve and will look something a bit like this. Crossing at minus 1.8, which you can see here, and also at 8. So where they're both greater than 0, if I just add on the solutions to this blue one, like so, there we go. The bit of this number line where both inequalities are satisfied is this bit here, not this bit here because any of the blue's satisfied, here neither of them are, and here 8 or greater is where both lines are in the picture and both lines are happy. So actually only both of these graphs, which are greater than 0, only works for when x is less than minus 7 or when x is greater than 8. So therefore what we need is either x less than minus 7 or x to be greater than 8. And that's the only way we can satisfy both inequalities, not just one or the other. That's the final question on the whole paper. So I hope you found that useful in some way, shape or form. I don't ever expect you to have watched the whole video. You probably have a life, unlike myself. But thank you very much anyway for staying with me. So if you would like to subscribe or leave a comment, please do. If not, then your choice. But hope you're well, and again, hopefully see you in class. Keep yourself safe and tune in until next time. Goodbye from me.